Hey everyone, how's it going? Dan here, co-founder of PromptUp. Hope everyone is having a great Friday. It's a little bit late here in New York, but just in time for another video. So, obviously, OpenAI recently came out with a new model that has really leaned into reasoning. Of course, if you use this in the ChatGPT interface or via the API, you'll see there's even a whole new kind of like reasoning tokens that it has when it's thinking to itself. But a question arises around the faithfulness of those reasoning steps and how much you can trust them and how much they align with the final answer. And there's a number of reasons why that's really important, and that's kind of what we'll be looking at today. And of course, obviously being very understanding, this is a preview of a new model, and it's great. We've used it for a lot of different things, and it does really well on certain tasks. But I would suggest you check out this blog post, which we linked below, from this site LLM Mindset in the UK. They basically ran a bunch of tasks using the new models, and what they found was around half of the runs included a hallucination or weird tokens in the chain of thought, and in some cases just hallucinations / wrong answers, as we're seeing here, where Alice gets a 10, which is correct, and then Bob gets a 2, and the output is actually a 3. But we're really focusing on those kind of chain of thought reasoning steps here. And this isn't a new concept in terms of the faithfulness of these chain of thought reasoning steps and how they can differ from what the model actually ends up outputting as a final answer. This was a paper from Anthropic back in July of 2023, so more than a year ago at this point. What they did, they tested how chain of thought reasoning could potentially be unfaithful via a few different ways. So one of them was called early answering, where basically they would truncate the chain of thought steps and see if the model still gave the same answer. Another one was adding mistakes, which was when they added mistakes into the chain of thought reasoning steps and see if that returned the same answers or not. Paraphrasing the reasoning steps, and then filler tokens, which is when they just replaced the reasoning steps with filler tokens to see, was the performance gains coming from just extra time to compute, or was it actually the reasoning steps? And we'll look at all of these very quickly here. So post hoc reasoning, and this is basically that first one of early answering. They basically truncated the reasoning chains at a certain step. It saw, hey, did the model still get to the same answer? So if the model arrived at the same answer, even with truncated reasoning steps, that would mean it was more likely to be unfaithful. And if it gave a different answer, because it didn't have all the other reasoning in mind, that would point out it's being more faithful. And you can see from the results here, it's kind of a mixed bag. In some cases, it was pretty unfaithful. In other cases, it was pretty faithful to those in terms of having a lower percentage of the same answer as the complete chain of thought. Something to note is that even for the answers when it was unfaithful, it still got a performance increase from the chain of thought prompting, which I think is quite interesting. You still get that performance boost even if the reasoning steps aren't necessarily faithful. Adding a mistake to a reasoning chain. So similarly, just putting a mistake in the chain of thought and seeing how that changed. So theoretically, if the model arrived at the same answer, then you would think it is unfaithful, meaning that the model was going to give that answer kind of no matter what, almost. And if it's at a different answer, then that would mean that it's like really following those chains of thought. And again, kind of a mixed bag, and it's pretty similar to the one before this. And something you could probably say as well is that even if we insert something that's incorrect and the model gives the same answer, so in this case it's unfaithful, you could say, hey Dan, that just means the LLM is smart enough to ignore that, and that's definitely true, and I was thinking that as well as I was reading through these. But it still brings up an issue where we have the ability to have reasoning steps that don't align with the output, which can be misleading. Next up was adding filler tokens, so replacing the reasoning steps with ... And the tester here was really to see, hey, does the performance boost from chain of thought come from just having extra time to generate an answer, or is it actually from the reasoning? And they compared the filler token to just when there was no chain of thought at all. And in theory, if you think it's just about time, then this should perform better than just the normal prompt, and it did not. So that signals that it's not just about the extra time, it's actually about the reasoning or the actual chain of reasoning steps. And the last one was paraphrasing. Again, if it was faithful, then the performance should stay the same, and the accuracy essentially matched the original, the non-paraphrased chain of thought accuracy. So specific phrasing doesn't really drive performance. It's more about the gist of the reasoning. And then the last section that I thought was interesting here is they kind of looked at this lens through the size of the model. And for 6 out of the 8 tasks, a 13 billion parameter model was the most faithful. Larger models were more likely to skip the reasoning process because they are, more confident. It's also known as the inverse scaling hypothesis, such that larger models are trained on more stuff, they've seen more stuff, so they're going to be, smarter and more confident, and it reduces their reliance on reasoning, which is great, which can be a very good thing, right? And it's kind of what you would expect, but you would still want it to follow in line with the reasoning steps. And then that's where you can get into really some weird situations where the model thinks it's right, but in fact it's not, and becomes very overconfident. We've all run into that before. Of course, this is a concerning trend, as models will just most likely continue to grow. We'll get some great small models as well, but the trend is larger. And so a couple of quick prompting methods to extract reasoning. So least to most is the classic one. We just wrote about this recently. All of our guides will be linked below. That breaks down problems into subtasks and then runs them sequentially via prompt chaining. Tree of thoughts is another good one where you have multiple reasoning paths to look at, and then pick the best one. And then multi-persona prompting, one of the first ones that we wrote about, where you can have 2 personas. You can even angle them to be more to debate more than collaborate, which is what the method that we wrote about is more about collaboration, but you have them debate, and that will show more of the reasoning. So just a few months after that original paper from Anthropic, researchers from UPenn released this paper about faithful chain of thought reasoning, and it is essentially a prompt engineering method that looks to kind of solve this problem of reasoning steps that don't align with the answer. And here's another example of when that happens. So you can see in this blue text here, we get a final answer of 200 in the reasoning steps, but then the model says it's actually 0. And so which one is right and which one's wrong isn't actually super important here, but more that they are different. And so faithful chain of thought reasoning prompting is a method to ensure that the reasoning steps in the output are aligned. And it's a little, of course, intensive to do this, but basically it converts a natural language into a symbolic format like Python code, and then has a deterministic solver basically solve the task rather than having an LLM do it, which of course removes the non-deterministic nature. Here are a few examples. There's also linked in our guide below, so I'm not going to go over them too much. And we also have a template that can help you generate that translation of natural language query into symbolic reasoning, and then you'd have to run it on your own Python interpreter. But that's it. It becomes, this stuff becomes more important as the models continue to get better at reasoning and making sure that, the reasoning tasks that they are doing for us aligns with the thought process and the output. Is going to be important as we continue to integrate these into our products, our lives, and our daily kind of workflow. So hope this helps. Have a great weekend, and we'll talk to you soon.